The last step is to test the connectivity of our IPsec tunnels. Remember, we will verify the existence and proper operation of the IPsec VPN, while hiding or maintaining the details as transparent. In order to do this, we will take a look at the main configuration components and some commands to verify that the VPN is working. Without going into detail, one of the main configuration components of IPsec VPNs is the crypto map. Crypto maps are configuration objects that group and gather VPN settings in order to apply them to an interface. Only then, when a crypto map is applied to router interfaces, will the router start encrypting and tunneling traffic through those interfaces. The components that comprise crypto maps define the type of traffic to encrypt via crypto ACLs. A permit statement in crypto ACLs means encrypt traffic. A deny means send it in clear text. Traffic defined by the CryptoMap ACL will be encrypted according to certain cryptographic algorithms and policies that are also part of the crypto map. Examples shown here include triple DES, AES, etc. Finally, additional parameters, such as the lifetime of the tunnel and the timeouts, are included in the overall configuration. The commands listed in the top right panel provide basic tools to help you verify the VPN configuration exists and is working properly. In our scenario, in the top left panel, the crypto map should be attached or applied to the internet-facing interface with an IP address of 192.168.1.1. If we use a show crypto map command, you will see that we have a crypto map attached to this interface. It is Fast Ethernet 0/1. Let's try to initiate an IPsec VPN from a remote client working on a laptop. For that, I will bring up the laptop itself. This is the Cisco IPsec software VPN client. I'm simply going to click Connect. The client looks connected. Let's display some statistics. Look at that. We obtained IP address 10.254.254.3, which is part of our pool. It looks like we are encrypting and decrypting traffic. Let's launch a few ping commands from the laptop. There you go. There is a host at address 10.6.6.7. This seems to be working. Our encrypted and decrypted packet counters are increasing. If we go back to our three-way panel, the other commands that allow you to determine whether the crypto tunnel is working appear. Perhaps the best way to know is the show crypto ISACAMP SA command, which should show with a status active. And there it is. For remote access VPNs in particular, a show crypto session is also helpful. It shows the session status, and it actually shows the IPsec flow that will be encrypted coming from that host on that IP address, which is part of our IP address pool. If you want to see packet counters increasing, your best option is Show Crypto Engine Connections Active. Here you see the packet counters for encrypted and decrypted traffic. If we ping again, this time we'll try to ping other hosts, those counters should be increasing. In fact, Let's try to test our connectivity to remote networks and the successful advertisement of the IPsec VPN address pool. We're talking about the loopback 10.200.200.1 on R2. If it is successful, it means the IP address pools are finding their way back into the laptop from the remote R2 location. Let's try that. This seems to be working. Let's go back to our counters. We see that the counters have increased. All of our configurations and the routing services we built around the IPsec VPN seem to be working. We have accomplished remote connectivity using IPsec tunnels. We are not only hitting or connecting to hosts behind our router R1, but also hosts behind router R2, including the loopback address. In summary, this demonstration allowed us into the world of provisioning and tuning services for remote access IPsec VPNs for mobile worker connectivity. We went through the steps of allowing IPsec traffic through the router's interfaces, then verifying VPN configuration, defining address pools, and bypassing NAT as services around the VPN. Our next lesson will allow us to debrief and summarize our findings.